예, 안녕하십니까. 애틀에서 온 김법균입니다. 예,
Nice to meet you. I'm Popkyun Kim from Etri, Korea. Slightly different from other presentations, we focus more on drones, so please understand we will be scaling down a bit and zooming in to a smaller scale. I hope we set that perspective before we start. At Etri, we deal with many different kinds of projects, and this particular one, again, deals with drones. The main concept of this project is not about building a new type of drone. It's about how to better utilize existing drone models to create better services with more higher value. The ideation of this project was based on a view that the market will develop more in service rather than the model itself of the drones. So if you look at the task at hand that we have worked on, the main idea when we began was that we will not build a drone. However, we later found out that we actually had to build a drone to be able to apply the ideas dealt with in the project. However, in the future, we are trying to define and discover more service areas, especially in communications and satellite. And that was the direction. And the data that is used there was the main focus. Rather than covering the overall information from the project, I'd like to focus more on the data side from our project. This is the gist of what we are doing. In the interest of time, I won't go into every single detail. However, to focus just on the few, N is for network, D is for data, A stands for AI, and I is the integration of all that. So that is the category that is listed, and to look into some of the key words here. Of course, accuracy is important, but since this is communication-based, we focus more on it being timely and in real time. So when there's a failure in operation, we didn't focus on correcting the accuracy into a half centimeter level, but we focused more on making it as recent as possible and detecting an error half a second earlier. That was the focus point. So to tackle that challenge and achieve our goal, we needed to make some changes to the drone system and its sensors. So I'd like to go into some of that. I blocked some of the categories of the tasks, and I would like to focus only on the blocks that are written in English alphabet. Those are relevant to today's topic, focusing more on data. In the center, it says workspace.
인데요. 이게 이제 어떻게 보면은 지금 현재 여러분이 직접 온라인상으로
And this is what you can experience in the real world on the web. So we do provide a web service where you can actually try it out. So we wanted to start with what we could actually put into use on the ground. So we did some research on that. We selected 4 areas. And one of those 4 was detecting and finding missing people. Missing people detection, when you're looking for missing people, the most important aspect is you do not want to miss that golden hour. And so we brought in drones and worked with the police department. We talked to the police officers to devise our scenario and how it would pan out in an actual case. The data collection was thought out as well, and through the pipeline, we wanted to discover areas for improvement and correction. And for AI image analysis, what areas we needed to update or sophisticate was analyzed. Next year, we will be coming up with a final report on this case, so you will be able to access them next year. And one aspect that we thought we need more is a data standardization, not just for drones, but data that can be transmitted to other types of services that are useful for analysis, and then the result of the analysis that can be applied to other services and being processed for a different purpose. Those life cycles and connecting with different life cycles on different services required data standardization. That is why we focused on standardization and standardizing data. And visualizing that outcome and result became part of the project. No matter how timeliness is important, you need a certain level of data quality to be maintained. These lists deal with that data quality side. We did modify the drone itself, and to have a good quality data, we did go through a process of selecting data, and the video frame itself we did not modify because there are excellent tools out there already available, and we wanted to make use of what is already existing. We did not trim or treat the video in any way. We only standardized the metadata of the imagery and visuals. And image encoders and manipulation of the speed and other features of the video, those tools were developed. These were developed in 2021, and starting last year, these are being scaled down so it can be mounted onto a drone. When we say drone, we're thinking of smaller models like Jetson Nano 5 or so, and we're trying to make it so that it won't interfere with the existing features. So real time is our target, and it does affect the accuracy level, because if you have a drone imagery, there's the point where it takes the image, but then the position of the sensor, the angle of it can change thousands of times in just 1 second. So you need to bring it down to the accurate point. And usually when you deal with drone imagery, you process it afterwards when the drone comes down to the ground. But then in between those 2 points, there can be some room for error as well. When you make adjustments, it may be still useful data, but we wanted it to be real time as much as possible. So that is where registration comes in. So the metadata is combined directly from the point where the drone is picking up the imagery. So let me talk a little bit about how data standardization happened with the sensor data. First step was modeling the data. The data that is generated had to be classified first. We looked at the sensor data output. We categorized them according to their purposes or use purpose, and we devised a data model with that. And from the sensor, again, a registration came in. We also surveyed a lot of different sensors, hoping we could find some sensors that met the qualification. However, there weren't as many as we hoped for. So we will be updating that information in the future. Again, I did mention this before, we did not edit or modify the video. And most of the video image was simply added. So if you already have a software that have these features and functionalities, you will end up with a better result and outcome. So this is a recap of what I was just talking about, what features were added. MISP is a STANAC military grade video that we used, and some of the added features you will notice are mostly about geospatial information or computation for processing geospatial information, and especially the position of sensors are the key aspects here. And drones moving and their orbit are part of their mission to begin with. So their position, their angle, and what drives that movement needs to be included in the data set. So that was added to the list as well. So this is how far we have come so far. This started in 2020. In 2021, the modeling was done. After that, we started standardization, and domestically, TTA started off. Let me make a slight correction here. And ITU standardization started in 2021. Sorry about the typo in the table. And this year, we are expecting a vote between July and September for selection of standardization. We wanted to go with the fast track, however, from Canada and from Europe, because of the characteristics of drones and the sensibility of the data it deals with, there are some regulations and some limitations. So to be safe, other members are looking into it. We are also updating whenever we have arising new information. So by the end of this year, we will see the final outcome. We have our hopes up. If you look at the main components listed, you see the content table, and part of the image shows you some information about the drone themselves and the flight data, and per sensor, what type of data is added and included. In the international standard, the LiDAR sensor aspect is not included. The LiDAR sensor is being pushed into the standardization process for the national standard. However, this will take some more time to reach the international standard level because we are currently working on it. Now on to data visualization. At the end of the day, data visualization is more focused on checking the data quality, but there are other advantages that come with it. Now, with the video imagery or aero photos, they can be added. And some of the outcomes have snapshots here, but later you'll be able to see it in a video clip. So this is the process of a drone taking a footage, motion image that is. It's from an actual drone flight and from NGII map. It is playing that flight record. The actual footage is the geospatial data that is mapped, and the drone is not in the image, of course, because that's taking that image, so it's outside that image to give you perspective on where the drone is. So this is just to give you a glimpse of what it can do, and you can expect what it may be able to do in the future as well. I hope this is inspiring some new ideas. And we did have a pilot project to test out some of the research and outcomes. Before I go into the details, going back to the missing people search, originally, according to our plan, we were trying to expand or help the missing gaps for communication towers. But 2 years ago, when we started this project, we started with areas that already had existing communication cable towers. And looking for good test sites was a challenge too. We ended up playing out this case on a campus, and this is the actual model that was put into that project. We only created the MC, and the FC was the one that came with it. That was the outcome, just for your reference. And this is the real-time footage we got from the drone. That's the aero photo mapped onto a topographic map that you see. And if you have a missing person in that location, the GPS coordinate will be detectable right away. Ideally, it would be within a second. At the current stage, usually it takes a police officer to manually check. But when you have a drone involved and using this service, it will be a matter of minutes before you detect a missing person. So that's all I prepared. Before I go, if I can add a few words, we are focusing on timeliness and real-time data, and enhancing the accuracy needs to be worked on with the drone models itself. And I think data quality enhancement can be worked on by working with the processing data after the drone hits the ground. And mapping is also a big part of this efforts. Thank you very much for your attention.